In the last class we talked about plane scales, and we have understood how scales are useful in drawing to get the length of actual objects. Although you draw an actual object, uh, the drawing can be much smaller than the actual object, or the drawing can be much bigger than the actual object. You can also draw something in the full scale. So to get the length of the actual object, we draw something called a scale on the paper. Now, and we talked about plane scales in the previous lecture, and this class we will be talking about diagonal scales. So the purpose of the diagonal scale is same that of the plane scale. The only difference here is that you use we get a much better accuracy when we take a diagonal scale. Now let's see how we do that. Let's directly start solving a problem here. Let's say we are being asked to construct a diagonal scale of representative fraction 3:100. And it must show meters, decimeters and centimeters. Now let's see how we can achieve this. First of all, we'll draw a line that is how long. Okay, it's a good idea to actually calculate the length of scale so that you understand the actual procedure. Length of scale is equal to RF multiplied by length of actual object, maximum length of actual object. So we need to measure up to 6 meters. So 3 divided by 200 into 6. So how much will that be? 18. So that will be 9 centimeter. This much meter is equal to 9 centimeter. So you draw a line that is 9 centimeters long. Now this must measure up to 6 meter. So you have to divide this into 6 parts. So divide into 6 parts. Mark 0, 1, 2, 3, 4 and 5, and these are meters. Okay, I'll do one thing. I'll just I'd rather use the actual procedure so that you really understand the standard procedures that we use for drawing. To divide into 6 parts, you can draw a line which is 3 centimeters long or 6 centimeters long, then divide it into 6 parts. 9 can be divided into 6 parts easily. Is it possible? 6, 3, yeah, 1.5. For 9 it's easy. 9 can be equally divided, so that won't be a problem here. 1.5, if you divide into one sections of 1.5, you get 9, so that's not really a problem. So we divide it into 6 parts and mark 0, 1, 2, 3, 4 and 5. Now we can show meters here, and that must also show centimeters and decimeters. So to show centimeters, just like we have already done, you can draw a line which is 5 centimeters long. Let's say I'm going to draw a line. I'm simply drawing it here so that it's we can use the top part for some other purpose. So we would like to divide this into 10 parts. Divide into 10 parts and connect this end of the line to this end and draw parallel lines from each of these points. Draw a parallel line from here, 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 and from all these points you can draw parallel lines. Now you have divided this into 10 equal sections. You can mark 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So now you have meters here and you have decimeters here. Now you must also divide each of these small sections into 10 parts, because you have to also show show centimeters. We have shown meters, decimeters, and now we have to show centimeters. So since it's extremely difficult for us to divide this very small part into 10 equal parts, what we do is that we draw a vertical line from here. Draw a vertical line from here which is 5 centimeters long or 10 centimeters long, something that can be easily divided into 10 parts. Then you do this. And let's say we just connect all these sections to the top so that you can measure. It's easy to find these positions. Now what we do is that we also divide this part into 10 equal parts. So you can use, if you have a mini drafter, it's easy for you, but since you don't have a mini drafter, you may have to do the same procedure here. Draw a line here, divide into 10 parts and connect parallel lines. That's what you need to do. But when you have a drafter, it's possible for you to mark this 10 points using these points, because you can it's easy for you to get vertical direction in a mini drafter. So for the time being, I'm simply dividing this into 10 parts without using any special technique. Now what you do is that you connect 0 to 1 connect 0 with 1. So the 0th point here is connected to first point here, and first is connected to second there, second is connected to third there. Yes. Yeah, here I could not actually match these lines, but you need to take care of that. So the idea here is that you connect the zeroth division to first division, first division to second division, second division to third division, similarly to the ninth division to 10th division. And next thing you need to do here is this vertical line which you have drawn in such a way that you can it can be easily divided into 10 equal parts. So it should have been either 5 centimeter or 10 centimeter. Divide this one also into 10 equal parts. Now connect each of this section to draw horizontal lines from each of these sections. Alright, now we can actually divide each of the small section into 10 equal parts using this vertical line. How is it possible? So this division here correspond to this division, and the line starting from 0th division and ending at the first division has been cut into 10 equal divisions in the vertical line, in the almost vertical line, and we can use this horizontal distance as smaller accurate distances. For example, in this case, let's say we would like to mark let's say 3 point. So this is now meter, this is decimeter, and this sort of represents millimeters. Now if you'd like to mark 2.3, so what you can do is that, okay, I'll just write these numbers here so that this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now if you like to mark 2.3, what you can do is that you can draw a vertical line from here. No, sorry, 2.3 is not accurate. You have to mark let's say 2.34. okay, 2.34. so this gives you 2, and until here you get to 2.3, and now you need 2.34. so go up the almost vertical line by 4 divisions: first division, second division, third division, fourth division. This point gives you 2.34. Draw a vertical line, and this gives you 2.34. now let's say you have to mark 4.68. okay, 4.68. for that you draw a vertical line from 4. so you have 4 here. Now what did I tell you? 4 point let's say 68, right? 4.68. so this is 4, and this is 4.6. okay, first, second, third, fourth, fifth, sixth, and this is 4.6. and on that line you have to find out 8. so that gives you 4.68. so this is now 4.68. So earlier in the plane scale you could have marked only for first decimal digit. So 2.3 or 4.6 could have been marked on the plane scale, but 2.34 or 4.68 numbers with 2 decimal digits cannot be marked on the plane scale. But in diagonal scale this is possible, and this is the advantage of the diagonal scale. Now let's see another problem. Let's say you are being asked to construct a diagonal scale of RF 1:4000 to show meters and long enough to measure up to 500 meters. So first thing you need to do is to calculate the length of the scale. Length of the scale is equal to RF multiplied by length up to which you need to measure for the actual object, so that you need to measure up to 500 meters. So 500 meters multiplied by RF 1 divided by 4000 gives you 1 divided by 8 meters. which is 12.5 centimeters. So draw a horizontal line 12.5 centimeters long. It must measure up to 500 meters. So divide it into 5 parts, and each of the part will represent 100 meters. Divide into 5 parts, and each of the part will represent 100 meters. Now what you can do is that you can further divide the smaller section, which represents 100 meters, into 10 equal parts, and each of the part will now represent 10 meters, right? This whole section represents 100 meters. If you divide equally into 10 parts, each of the section will represent 10 meters. And this is just like the plane scale, simply divided into 10 parts. Now each of the small parts represent 10 meters. So each of the small part can be divided into 10 different parts using the idea of diagonal scale. For that, you draw this rectangle, draw the top part into 10 equal parts, connect 0th division to first division, first division to second division, second division to third division, etc. up to 9th division. Once you have that, you can measure any length. In this case, let's say, so what does AB represents? AB represents this is 50, this is 60, this is I think 70, 50, 60, 70, 80, 90, 100, yeah, this is 70. So AB is 300 plus 70 plus 4. So we have 3 parts here, each of the part represents 100 meters, so 300. Here 7 parts, each of the part represents 10 meters, so 70, and each of these parts in the vertical line, the nearly vertical line, represents meters, and so forth. So line AB here shows 374 meters. So if you have to mark let's say 208 meters, to mark 208 meters, should start from here and 200, and how many 10 meter divisions do you need? 0. So start from here and go until 8. Okay, sorry, so you should start from here and until here. You can also draw a vertical line. Okay, you can also draw a vertical line from wherever you like and mark the corresponding point. So this will be 208 meters. 208 meters. Let's see another problem. In this particular problem, you are being asked to draw a diagonal scale of representative fraction 1 is to 2.5, showing centimeters and millimeters, and long enough to measure up to 20 centimeters. So as usual, you find out the length of the scale first, which is RF multiplied by maximum length you need to measure, which is 20 centimeters. So 1 divided by 2.5 multiplied by 20 centimeters, which is equal to 8 centimeters. So draw a line 8 centimeters long, and so you can divide it. You can actually use your logic and divide it into how many parts you like. If you can, here they have divided into 4 parts first. If you would like, you can also divide into 8 parts if you like, that is also possible. So you have the freedom to choose how many divisions you want to make it, but that should be suitable for a division using diagonal scale. Here they have first in this particular example they have first divided the total length into 4 parts, so it should measure up to 20 centimeters. So if you divide 20 into 4 parts, each of this part measures 5 centimeters, and 5 centimeters can further be divided into 5 parts, so each of the small part will represent 1 centimeter. Now each of the small part 1 centimeter can be further divided into 10 millimeters, again using the idea I've described. So just the way you have divided into 5 parts here also you divide into 5 parts. Connect 0th division to first division to second division to third division, etc. And then you can mark once this is done, you have a good accuracy, and you can show for example in this case let's say you want to show 13.4 meters. So bigger division, how much? 5 plus 5 or 5 into 2, which is 10. Smaller division 3, so 3 into so each of the smaller part represents 1, so 3. And each of the upper division here in the vertical direction, the nearly vertical direction represents millimeters, so at the 4th division the point is marked, so 0.4 centimeter is 4 millimeter, so this gives you 13.4 centimeter. Similarly you can mark any other distance. Let's consider one last example. In this case you are being asked to construct a diagonal scale of representative fraction 1:32 showing yards, feet and inches. So you have to show yard, feet and inches. This is slightly different because you need to know how many feet is 1 yard, you need to know how many inches is 1 foot. So here like in case you don't know, 3 feet is 1 yard, 12 inches are 1 foot. So here you need to measure up to 4 yards, right? 4 yards. So first thing to do is to calculate the length of the scale. Length of the scale is equal to RF into length up to which you need to measure. So 1 divided by 32 multiplied by 4 yards, that gives you 18 yards, which is 4.5 inches. Or you can convert it to any other unit. You can convert to centimeters if you like, no problem. So draw a line 4.5 inches long, and that must measure up to 4 yards, hence divide it into 4 parts. Take the first part and divide into 3 parts, because each of the yard is equal to 3 feet, and then each of the feet should be divided into 12 inches, hence you draw 12 vertical lines here, 12 horizontal lines here. So this height should be in such a way that you can easily divide into 12 parts. So of course, to get this mark these lines, you know how to do. If you divide this section into 3 parts, you also divide this part into 3 equal parts and connect 0th division to first division, first division to second division, second division to third division. Now let's see what is the length. PQ represent here. This is connected to first division in first large division, which is 1 yard, and then this is 2 feet here. This is 1 yard, 2 feet and 7 inches. So PQ here represents 1 yard, 2 feet, 7 inches. So we have considered different types of problems for diagonal scale. And here one more thing to one more point to remember here is that these divisions in this particular case, it seems very logical to use yard, feet and inches here, because if you divide it in this way, you have yard here, feet here and inch here, which is a very natural choice for you. But for the cases like these, you actually have a choice to decide how many parts should you have, and that should depend on the total length up to which you need to measure and what kind of accuracy you need. So I will conclude here, and in the next class we will start talking about vernier scales.